Okay, this example is on using 4 to 1 mux or 2 to 1 mux to implement a function, and the function that we're going to start with is the f min term 1, 2, 4, 7. So x being the MSB and z being the LSB. So what we're going to do is we're going to use Shannon expansion to help us figure out what are these control signal, what should be tied here, and what are the data bit. So we have x, y, and z, so we got to figure out where things go. So Shannon expansion is going to help us. So this is how what we're gonna do to start. So we're just gonna write out everything. Write out, no simplification. Okay, just write out. Just write out all the mean terms. So 1 is 0, 0, 1, 2 is 0, 1, 0, 4 is 1, 0, 0, and 7 is 1, 1, 1. So and then the way Shannon expansion work is you pick a variable, pick whichever variable that you want to work with, and you're going to divide it into two camps. So let's say we pick x. Okay, and we have the x naught. Okay, and we have x. Okay, we have x and x naught. So now you look at those that will have x naught is right here. Okay, so since we factor out x naught, we have y naught z, y z naught. Okay, and then the next one is we have the x, and then we have y naught, z naught, and yz. Okay, so let's work on getting it implemented with 4 to 1 mux first. For 4 to 1 mux, look at this, right? This right here. Now let me see. Let me use the right color. Okay. For this right here, the green arrow x, the things that we're pulling out, the variable that we pull out for this particular one is x, is actually the control signal or the select signal. So these are the thing that is gonna go right there. All right there. Okay, so since 4 to 1 for 4 to 1 mux we need 2 control signals, so we need to do it one more time. So we're gonna need one more variable. So we leave the outside alone, so we could use y or z. Let's use y. So again, the inverted form z, and y, the true form z naught. So we x, leave it alone, y naught again, and y. Okay, now we have this. So you see that these, everything on that last parenthesis right there, these are what you're going to tie into the data input. Okay, because this is location 0, 0, and this right here is location 0, 1. This is 1, 0, and this is 1, 1. So if you look at the 0, 1, okay, everything in the most inside parenthesis is what going to go into the data. So this is 0, 1, 2, 3, right? 0, 0, 0, 1, 1, 0, 1, 1. So we have z, z naught, c naught, and z. And we have y and x. Okay, if we are going to implement it so this is basically the implementation for 4 to 1 mux. If we are going to implement it with 2 to 1 mux, okay, we are going to use, so this, using that, we are going to use this one. Okay, so we have the control bit, which is x, And then we have the Y. Y is the 2 AND gate with the OR gate. Okay. We have the Y going in here, Y inverted, and we have Z. Okay. And then the other one we also have Y and Z. Okay, this is the implementation using 2 to 1 mux. Hope this helps.